Okay, so this is the homework, okay, for the finite line, biot savart finite line. So you have a conducting triangular loop, okay, as shown in the figure, and it carries current of 10 ampere. Find the H at this point, okay, P005. Okay, so this is side 1, side 2, and side 3. So actually this question wants you to find the magnetic field due to side 1 and also side 3. It's not side 2, okay? So the option below here is all meant for the side 3 and also side 1. So I put the wrong thing here. Okay, never mind. Let's look at the solution for side 1 and also the side 3. Okay, so this is side 1, this is side 3. So we have to look at each of the side one by one. First of all, let's look at the side 1. This is the 3D drawing for side 1, okay? Okay, from 0, 0 up to 2, 0, okay? 0, 0 up to 2, 0, and this is the observation point. So first thing that you have to do is to find the T point, okay, which is this point. Okay, so T point will be located along the axis that has the current filament. Okay, so along the x-axis, okay, we are very sure that the y and also z are 0. Okay, y and z are 0. So for the x, we just follow the x of the observation point, which is 0. So from the T point, we can find the vector r. Okay, vector r, which is the observation point minus the point T. Okay, which is equivalent to 5z. Okay, so the magnitude of the r will be 5, and then the unit vector r will be z. Okay, now let's look at how to find the angle. Okay, how to find the angle. So I redraw a diagram. So this is your observation point, 0, 0, 0, 5, 0, 0, 5, and this is your point T, and this is your point B. So when I link this one and this one together, this is point B, and this one will be your point A. Okay, so point A is here. Okay, so the angle for alpha 1 is this one, and alpha 2 will be this one located inside. So for alpha 1, it should be 90 degrees. Okay, so I will correct it, 90 degrees here. Okay, so it should be 90 degrees. Okay, 90 degrees. Okay, and for alpha 2 is here, so you use the tangent to find it, which is 5 over 2. Okay, 5 over 2, you get this one, 68.199 as your angle for alpha 2. And after that, you plug in the angles into the equations. This is your I, this is your R angles, and also the phi will be dl cross product with the unit vector r. So if you look at this current filament, it is flow in the x directions. So this one is x, z, you will get negative y, and here you will get 0.0591. So your answer for the side 1 will be negative 0.0591 unit vector y. As for your side 3, this one is your side 3. Side 3 is from, okay, if you look at your side 3 is this one. Okay, from here up to the origin. So up to the origin. Okay, so first of all, you also have to find the point T. So in this case, point T will be equivalent to 0, 0, 0 as well. Okay, when you extend it here, 0, 0, 0, and unit vector r will be 5z, magnitude will be 5, unit vector r will be z. Okay, and next we find the alpha 1, okay, angle alpha 1 and alpha 2. So this is point T, 0, 0, 0, and this is point B, this is point A also. Okay, so like just now, alpha 1 will be 90 degree. As for your alpha 2, it will be 5. Okay, this one is the magnitude of vector r, so it is 5 over square root r, square root 2. So this one you can get is value, okay, by using this thing. Okay, so this one is a triangle, so this is 90 degree, this is 1, and this is 1, right? Okay, if you refer to this one, okay, this is 1 and this is 1, you can find the length here. So the length here will be equivalent to square root 2. So your alpha 2 will be 74.21. And next is this one, okay, dl. So this in this case, this is your current filament, okay, is dl is in this direction, which means that it move here and then here. Okay, so we have to take the coordinate and minus both of the coordinate in order to get the dl. So it will be 0 0 0 minus 1 1 0. Okay, so it is this one, and we only want to know, okay, sorry, this is the magnitude, okay, square root 2, and the dl will be this one. Okay, the dl will be this one. So the unit vector phi will be dl cross product with the unit vector r. Okay, so negative x, z you get positive y, negative y, z you get negative x. So this is your unit vector phi. So you plug in into your final equation, and finally you can get this answer as the answer for the side 3. Okay, now let's look at the second questions. So okay, this is the question, okay, for the scope of infinite line. Okay, but I think the question for infinite line is quite simple. Okay, so I will just continue with the exercise for the finite, okay, length. Okay, so here you have a square conducting loop 3 cm on each side. Okay, and it carries currents of 10 ampere. You have to calculate the magnetic field intensity at the center of the loop. Okay, at the center of the loop. Okay, this one. So imagine you have a square, you have current. So actually you can place your square, okay, to the coordinate system. So imagine if this is side 1, side 2, side 3, and side 4, and the length is of the sides is 3 centimeter. Okay, 3 centimeter here, which is 0.03. So you have to find the total magnetic field at the center, okay, which is 0.015, 0.015. So let's look at the side one by one. So for side 1 is this one, side 1. So I draw it separately. First of all, you have to find the point T. Okay, so point T will be here. Okay, so point T will be here. Okay, so point T will be the observation point, okay, minus the source point. Okay, so for first of all we have to find point T. Point T is 0.015 right here. Okay, so I will get my vector R equivalent to this one, and my magnitude for vector R will be 0.015, and the unit vector R will be x. Okay, and next, okay, we have to find the alpha 1 and alpha 2. This is point P, so this is A and B. Alpha 1 will be outside, alpha 2 will be inside. Okay, so for your alpha 2, we will look at this triangle. Okay, so it will be the magnitude of vector R. Okay, divide this one. Okay, this one is length is 0.05, so you get 45 degrees here. Okay, so the total length is 0.03, so half of it is 0.015. And for the alpha 1, okay, so we use the opposite adjacent. Opposite will be this one also. Adjacent will be this one. And alpha 1 will be 135 degrees. So this is your alpha 1 and alpha 2. As for your unit vector phi, so the dl is in the y directions. Okay, y direction, negative y directions. And your unit vector r is x. Okay, that's why you get z. Okay, so when you replace all the value into the equation, you will get this one as the magnetic field contribute by side 1. And let's look at the side 2. Okay, for side 2, the coordinate of point T will be 0.015 and 0. so the unique vector, so the vector r will be 0.015 unique vector y. Okay, so it is observation point minus the source point t. Okay, so your vector, the magnitude of vector r will be 0.015 and your unit vector r will be y. Okay, so this one, okay, its condition is very similar like the side one. Okay, when you connect them, okay, the end of the line, this is a and b. Okay, alpha 1 is here, alpha 2 is here. Okay, so this one will be your magnitude of vector r. So we don't need to calculate anymore. So for alpha 2 it is 45 degrees, and for alpha 1 it is 135 degrees. As for the unit vector phi, okay, this round your current is flow in the positive x direction. Unit vector r is y, so you will get z. Okay, so you plug in again all the values, you will find that the magnetic field at the observation point will be 75.03 in the z directions. So I do not repeat for side 3 and side 4, but you can try. But for these two sides, okay, they are having the same magnitude and direction of as the side 1 and also side 2. So the total magnetic field will be, you just multiply 4. So the total magnetic field at the center of the square loop will be 300.12, and it is in the z directions. Okay.